So all of you know speed is equal to distance by time, correct? Speed into time is equal to distance. This is equation number 1. Equation number 2. Equation number 3 is time is equal to distance by speed. So all of you know this formulas. You have been studying this. You have already studied this formula in your school. Okay. So these are the general formulas for time and distance. Now coming back to train, the formulas would
Sir,
differ.
unable to hear your voice, sir.
Who is not able to hear? Hello. Who is that? If you can.
Sir,
Yeah, Habiba. Yeah, can't you hear my voice? All of you, please tell me. Hello.
मदर
Can
आवाज
all of you hear my voice?
Yes, sir.
Yes,
Yeah,
sir.
yeah. If you can't hear, you again rejoin, please. Yeah. So speed is equal to distance by time. Speed into time is equal to distance. So you know, if someone asks you, what is the speed by which the car is traveling? That means the car is the car is raised or the car is like traveling. So how will you find out the speed of that car? The distance would be given to you 500 kilometers, and time would be like it takes how many hours for you to reach that particular 500 kilometers, for example 10 hours. Okay, speed. So what is the speed the car is running with? Correct or wrong? 50 kilometers per hour. What I'm saying, correct? How did you get this 50 kilometers per hour? If I take 10 hours it takes for me to reach some destination. 10 hours is 10 hours it takes me to reach some destination, and I'm going with the speed of 50 kilometers per hour. So this is time, this is speed. So the distance is correct or wrong? 500. Yes. So distance is equal to time into speed. So you can understand that the formula for speed is distance by time. The formula for distance is cross multiplying here, speed into time, and the formula for time is distance by speed. Now point number 2. See, in the question you may get some scenarios whereby things will be given in kilometers per hour, and you need to convert this kilometer per hour into meter per second. So how will you do that? Please try to understand. If it is 3 kilometer per hour, if you want to convert 3 kilometer per hour into meter per second, the formula is 3 into 5 by 18 meter per second. And if they give you meter per second, so if you want to convert 3 meter per second into kilometer per hour, so you'll do what? 3 into 18 by 5 kilometer per hour. Correct? All of you please make a note of this. That means 1 kilometer per hour is equivalent to 5 by 18 meter per second. So 3 kilometer per hour will be 3 into 5 by 18. And 1 meter per second is equivalent to 18 by 5 kilometers per hour. Now, let us move forward. See, in the chapter called trains, you will be coming across certain cases. Okay, and they will be asking you either find the speed of the train, either they'll be asking you find the. Okay, let me, before going into the the problems what they can give, first let me explain you the concept of trains. Okay, Okay, yes, you joined now. Fine. So let me first explain you about the problems, about the questions or category of questions what they can give in problems on trains. Okay. So what kind of questions you can get is a secondary matter, but first you should learn the concept. What concept is behind the problems on trains chapter? So let us see the concepts. See, you know, always the basic formula for speed is distance by time, correct? So taking this distance by time formula as a base, we would now try to derive the formula for four cases. Okay, these are the four cases which you will come across in problems of trains chapter. Case number one. So I will make the I'll make a tabular form here. Case one. Types of objects and time to cross. Okay. So now see, there may be a train, and a train, you know, this is a platform and this is a railway track. Okay. So the first case is case number one. There is some person standing here, and this person is not moving. He is stationary, or there can be a pole. Okay. There can be a pole, and pole is a stationary object. You know that pole doesn't move. Or there can be a pillar which gives support to the base, to the slab. Okay, so all these are stationary objects. There are more stationary objects. Platform is also a stationary object, and the train which crosses a bridge also is a stationary object. So point number one is, but all these stationary objects, there will be some differences which we need to know. For example, if I take a man, man doesn't have a length. When I speak about man, there is no length what man has, but platform has a length. Pole doesn't have a length. Bridge has a length. So we should see the cases, what kind of cases they are giving in the question to analyze. Case number one, object is stationary and is of negligible length. Time to cross, that means which will cross here? Train. So what time train would take to cross, that we are seeing. Okay, either train would cross the object which is stationary, which is nothing but a man. Either train would cross a pole which is a stationary object. So this stationary object which I am speaking, does they have length? Do they have any length? Please tell me. No, they have a negligible length. So object is stationary and is of negligible length. So what I'm speaking here, example also I would give you. Train. So now a train is crossing. Now you'll be asking me a question. What is the stationary object? So I'm writing the examples of stationary objects. Train crosses a lamp post. Lamp post is a stationary object with negligible length. B, standing man. And in some cases you can take standing car also, like the parked car. So all these are the examples of objects which are stationary, which doesn't move, and they don't have length at all. That means when compared to train, they have very small length, negligible length. Negligible is nothing but almost like almost that cannot be considered as a length at all when we compare to the size, when we compare with the length of the train. Okay. Now what is the formula behind this? How will you find out the time to cross? So here what we are doing, we are finding the time taken by the train to cross a object which is stationary and which is of negligible length. So my question would be find the time taken by train to cross a man standing on a platform. So such kind of questions would be given to you. So answer for such kind of question would be time is equal to distance by speed. You already know. Time is equal to distance by speed. So here what is the distance? The distance is nothing but length of the train divided by speed of the train. Okay. So I'm writing here length. I'll write it here. Length of train whole divided by speed of train. All of you make a note of this. So it is distance by time, distance by speed. So distance here is nothing but whose distance? Distance is nothing but the length of the train. Length of the train would be some meters, and distance can also be in terms of meters, correct? Suppose the length of the train is 200 meters. Distance can also be 200 meters. So length of the train I am taking as distance, and speed is nothing but speed of the train. Why? Because the object is stationary, object is not moving. So what is moving? The train is moving. So the speed of the train only we can take into consideration. Okay. Point number 2. Point number 2. Object is stationary. Object is stationary, but object has certain length. Okay. And is of some length. All of you please make a note of all this. Simultaneously you can write. So I'm speaking about what? I'm speaking about train crossing a bridge, because bridge has some length. Train crossing a tunnel, a platform, or even another train. This is also a example. Okay. So what can be the formula for, if the question is given to you, if the question is given to you, time taken by train to cross a platform, a bridge, a tunnel, or a standing train is nothing but length of the train plus length of the object, because object has certain length, divided by speed of the train. Why? Because speed of the object here is 0, because the object is stationary. Please make a note of this. Okay, next. Point number 3. See, point number 3 is object is moving. Here we are coming into such a case whereby the object is moving. That means a man is moving, a car is moving. So object is moving and is of negligible length. So we are speaking about example, train crossing a running man, a running car. Okay. So what would be the formula you should apply for this? So the question would be, find the time taken by train to cross a man who is walking or who is running, or a car which is running. Okay, so the time would be length of the train, and object has negligible length, so length of the object is 0 because it has negligible length, divided by speed of the train. Speed of the train, any clue what the formula would be? Minus speed of the object. Now why this is, I will tell you. First you write it down. See, the statement is very simple and clear to understand. If a train of length capital L, so train has some length, suppose train has a length of 300 meters for example. So I'm just putting all the things here and trying to explain you with the help of some numerical figures. Okay, so if a train of length L, so I'm taking the length of the train as 300 meters, and the speed of the train also I'm taking here, v is equal to, let us say, I'm taking it in meter per second. No dispute. Actually, train won't travel in meter per second. It travels in kilometers per hour. Okay. So let's say 30 meters per second. For example, just to prove you. So length of if the train of length L at a speed v, length of the train, speed of the train, passes another object of length L. So the length L I'm speaking about is, suppose, length of the platform. It's like 100 meters for example. Okay, at a speed x in time t, we will not say platform, let us say this one as uh, we can take this length of the train, speed of the train, and just a second, we can take object which is not stationary. Let's take a train crosses a running train. Okay, so if the length of a train L at a speed v passes another object, this is the length of the train. Let us say this is a uh, what we can take is another train. Let us take train 2, length of the train 2. Okay, so what is happening? If the train of length L, that is LT1, train 1, at a speed V, speed VT1, the speed of train 1, passes another object of length L. So here I am taking another object as train 2. So train 1 is passing through train 2 or crossing train 2. So length of the train 2 is LT2, that is 100 meters. And speed of the train T2, VT2 is equal to 20 meter per second. Okay. Now, So now you need to find out the time taken by this train to cross this train. Okay. So how will you find out? Put the things in the formula. Length of the train 1 is 300. Length of the train 2 is 100. Speed of the train 1 is 30 minus speed of the train 2 is 20. Why are you subtracting this? And here one note also you should write down. Please write down the note. This relative speed is in the same direction. Okay. So in case of same direction, you should take v minus x because they are going in the same direction. If it is in opposite direction, then in opposite direction. The same formula, if I give you in case of opposite direction, the formula would change into length of the train 1 plus length of the train 2, which is small l as per the above statement, divided by speed of the train 1 plus speed of the train 2 if it is in opposite direction. Okay, so if it is in same direction, you should take minus negative sign, and if it is in opposite direction, you should take plus here. That means minus v minus of minus x. Okay, please make a note of this. So relative speed, what do you mean by relative speed? If they are moving in same direction, the difference in the speeds we would take. If they are moving in opposite direction, there also we will take the difference in speeds, but the train which is coming from opposite direction will put minus to that. See, relative speed formula is always, see, what do you mean by relative speed? What do you mean by relative speed? The difference in the speeds. The difference in the speed is what? 30 meter per second and 20 meter per second. What's the difference? 10 meter per second. What are you trying to understand with this? When we are trying to compare the speed of this train with this train, what we are finding is this train is moving 10 meter per second faster than this train. Correct or wrong? Because this train is crossing some particular 1 meter in this train is crossing some 30 meters in 1 second, and this train is crossing 20 meters in 1 second. So which is more faster train? All of you tell me. Hello. Which is a faster train here? Yes, all
L1
of you.
sir.
Huh?
L1 sir. मतलब, which moves at the speed of 30 meters per second.
Yeah, it is understood fact. This
Yes sir.
particular train is crossing 30 meters in how many seconds? Per second, 1 second. This train is crossing 20 meters in how many seconds?
20 seconds.
1 second, na, per second.
Sorry sir. 20 meters per second.
Yeah. So here it is understood fact that this is a faster train, this is a slower train. The faster, this is faster than this by how much?
10 meters per second.
10 meters per second. The relative speed, the difference in speed, that's it. Whenever I speak about relative, it is difference. Okay. But when they move in the same direction, we just find out the difference. Here also, when they are moving in opposite direction, we are finding the difference. But since it is coming from the opposite side, we take this x as minus x inside the bracket. So minus into minus would become what? V plus x. Okay. See, I'm just showing you neatly. Please understand. 10 kilometer per hour, 5 kilometer per hour. This is train 1 speed and this is train 2 speed. So this particular train is going 10 kilometers in 1 hour. This train is going 5 kilometers in 1 hour. So what is the relative speed in them? What does this relative speed mean? The relative speed means that when we just try to relate them, or compare them, this is 5 kilometer per hour more faster than this train. Correct or wrong? When I speak about speed, I speak about fast. Correct? So this is 5 kilometer per hour more faster than this. That means this is going 10 kilometer in 1 hour. This is going 5 kilometer in 1 hour. So this is traveling more 5 kilometers than this in 1 hour. Correct? Correct or wrong, all of you?
Yes, sir. Double fast.
Yeah, this is just
Yes, sir.
double. This is just traveling the double distance in 1 hour. What this is taking, what this is traveling is single of this. Correct or wrong? That means if that travels 5 kilometers in 1 hour, this is traveling 10 kilometers 1 hour. So it is taking less time. Fine, because it is more faster. So it is more faster. How much faster? It is faster by 5 kilometer per hour. That's it. So when we speak about relative speed, we have to find out the difference. To find out which is the difference in the speed. Okay. So difference in the speed is very clear. But when it comes to opposite, this is in the same direction. So the formula for relative speed is very clear. V1 minus V2. This is the formula for relative speed. But when it comes to opposite direction, V1 minus of minus V2 would come into the picture. Okay. So minus sign is here, minus sign is here. The sign is not changing, but what is coming in the inside the bracket? Minus V2. Why? Because it is coming from the opposite direction. So it becomes V1 plus V2. Now, last and see, three cases are done. Last and final case. All of you try to understand case number 4. Okay. Case number 4. Object is moving and has some length. So here we are speaking about a train crossing another train. Okay, and the train which is crossing another train, that means train 1 crossing train 2, the train 2 is also moving because object is moving and has some length. Okay, this is not a stationary object. Now, example, train crosses another train. So here what I'm speaking is there is one train, train 1, it is crossing train 2. Okay, so they are asking us find the time taken by train 1 to cross train 2. But the thing here what we know is this is a moving train and this is also a moving train because object is moving and has some length. So this train is moving and it also has some length. The same case which we discussed above. So what is the formula? Time taken by a train to cross another train which has some length and which is also not a stationary object. That means which is also moving. The formula would be length of the train 1 plus length of the train 2. That is, we will take that train 2 as object. Okay, divided by speed of the train 1 minus speed of the object. Here object means train, moving train. In fact, all of you write on the formula.
Written, sir.
Yeah, hello.
Done, sir. Done.
Yeah. So all of you, I have given you the formulas. Once again, I want you to refer the formulas. Please see here the screen because I'm going to give you a couple of questions right now. You need to solve and tell me the answers. So I'm again bringing this down, bringing this up, scrolling up, and you start again reviewing it once again. Come on, from here. So very simple, object is stationary. That means some man is standing on the platform, railway platform, or there may be a lamp post. or there may be a parked car, and all this are stationary, not moving, and they don't have length even. So they have negligible length. That means that length is not even not to be considered at all in comparison of a train. So the formula would be very simple. Speed is like we are finding out time is equal to distance by speed. So distance here would be only one thing which we need to consider, that is the train's length. So length of the train, length of the object is 0. Why? Because it is a object which is first of all stationary but having a negligible length. Negligible length is nothing but L naught, that is the object's length is 0 because it is having negligible length. So length of the train plus length of the object, which is 0, divided by speed of the train minus speed of the object is also 0 because it is a stationary object. So first formula is clear. Formula number 2. Object is stationary, that is object can be a bridge, a tunnel, a platform or another train, but it has some length. So what would come? So train taken by a train to cross a bridge, a tunnel or a platform is nothing but length of the train plus length of the object. Object here would be the length of tunnel, bridge or platform, divided by speed of the train, because speed of the object is 0. It is a stationary object. Stationary object but has some length. Point number 3. Here object is moving and is of negligible length. That means train is crossing a running man, a running car. The object is moving, of course, but you know this particular objects, do they have some length? The length is negligible, but speed can be considered. Okay, length is negligible but speed can be considered. Why? Because they are moving objects, they are in movement, so they'll move with some speed. So length of the train plus length of the object is 0 because it is negligible object, it is object with negligible length, divided by speed of the train minus speed of the object, relative speed formula. Again we can relate and we can understand which is a faster moving object with the help of that formula. Fourth point, which is the final point, you have to find out the time taken by a train to cross a object which has some length. That means I am speaking about train, and this train is even some train which is a moving object, a moving train. Okay, so when it is a moving train, it's a moving train, it is an object which has a length and also which has some speed to move. So length of the train, train number 1 or the first train, length of the train number 2 or the object which we are considering as object, speed of the train 1 minus speed of the train 2, because train 2 is also moving. Okay, so we are putting this here, and this is the relative speed formula. So with this you can get the time taken by a train to cross another train which has some length and also which is moving with some speed. Fine. So all these 4 formulas are very clear. I've given a small brief revision even. Now you should solve these questions which I'm giving. Come on, this is your turn now. So you should see the situation and put into the formula. That's it. If these formulas are not given to you, solving train problems would be very tough. See, now some hint I am giving you. Now you should, with the help of that chart which I have given to you, try to understand. When I am speaking about telegraph post, this is a object which is of negligible length and which is also stationary. Correct or wrong? So negligible length is nothing but L naught will be 0 and stationary is nothing but speed would also be 0. So what is the formula? Length of the train by length of the train plus length of the object, which is 0. Speed of the train minus speed of the object, which is 0. So time taken would be t is equal to, what is length of the train? 110 meters. What is the speed of the train? That now I have given the hint to you. Now you should solve now. Okay.
सर
Yes. Yes.
सर वो क्वेश्चन के ऊपर वो एक एडी बोल के स्क्रीन आ रहा है, वो ऐसा ही है या सिर्फ मेरे को आ रहा है?
कौन सा स्क्रीन?
ओके सर, थैंक यू सर, दैट्स इट। हाँ यही जो आ रहा है, हाँ अब परफेक्ट है सर।
This is 170 meter. Okay. All of you make a note of this and start doing the question.
Sir, for first one 66.
Hello.
Sir, for
Hello.
first one 66 seconds.
66.
Yeah, sir.
No, it's wrong. Solve this. I am on a call. 2 minutes. Okay. Yeah. Are you
सर
doing the question?
सर
10 minutes. Hello.
सर
Hello. Yes.
सर फर्स्ट वन का 1.83 सेकंड्स.
First wala.
हाँ सर.
First one is 6.6 seconds.
6.6 seconds.
Yeah. Yes, Hashita, you're doing this? Hello?
Sir.
Yeah, did you get the answer for the first one?
I got 11 by 60, sir.
See, I am telling you one thing. What trick they played is you are not understanding the trick. Please understand. First, you convert this kilometer per hour into meter per second. Why? Because train is in terms of meter and this is in terms of kilometer per hour. So there is no compatibility at all. Convert this into meter per second and you can do the question. So I'll solve the first one for you. All of you, please watch. That first basic thing you should understand. So see, the question is, first I'm converting 1 kilometer per hour, is nothing but 5 by 18 meter per second. Okay. So now 60 kilometer per hour, I'm converting 60 into 5 by 18 meter per second. Let me keep like this. Okay. Now, length of the train is what? 110. So first one is telegraph post. It has negligible length. Divide by speed of the train. What is speed of the train? 60 into 5 by 18 minus object is not moving, stationary, 0. So let's solve this. 110 into 18 whole divided by 60 into 5. This 18 would go up. Okay. Now you can solve this. What are you getting?
6.6 seconds.
22. So why should we cancel? It is like 22 into 3, 66. 66 by 10, 6.6 meter per second. All of you solve this. That one thing you should know, the conversion part. They will trick you like anything. Now after this I have solved, I expect from you all the answers. I'm giving you some like 10 minutes to solve. You take your 10 minutes. I'm calling you back in 10 minutes. We'll do some more questions. Come on. Continue. Calling in 10 minutes. All of you solve these questions.